Hi, I'm Andrew Connell, and I'm an MVP for Office Servers and Services and Office Development. In this module, we're going to talk about authenticating and connecting to the Microsoft Graph, and this first section is going to deal with the authentication overview. We're going to cover the OAuth basics, some endpoint versions, key improvements with the V2 endpoint, talk a little bit about JWT tokens, types of flows, and obtaining a token and connecting with the Microsoft Graph. Every scenario has these basic parts. There are various implementations, but the premise is the same for all. Both the client and the resource server need to know about the authorization server, in this case, Azure AD. So the idea here is to get access, for the user to get access to the data. So there's our user in the bottom left-hand corner. What I first have to do is give access to an application. So maybe a native client or a web application that you see in the top left. I need to give it access to get to the resource that I'm trying to get to, which is in the top right corner. The way I'm going to do that is by handing it a bearer token or an OAuth token. What I first have to do is go to the authorization server and tell it that I am giving the application access to the resource. So then I'm going to first log in, and then I'm going to go to the application and tell the application to go access the resource on my behalf. The application is going to talk to the authorization server to get a token that the OAuth client is then going to use to go access the resource server via some API. Now, we have different endpoints available to us with Azure AD. The V2 endpoint is going to include some breaking changes to the protocols, and this is why it is V2. It's because the protocol is a little bit different and it requires new client library implementations. The Azure Active Directory V2 endpoint is a converged authentication process which accepts sign-in from both Microsoft personal accounts, also referred to as the Microsoft account or MSA, or a Live ID, as well as Azure AD work and school accounts. It enables the same code for using the Microsoft Graph for things like reading mail or retrieving contacts. It also enables dynamic consent, which is requesting permissions only when you need them and not having to define all of them up front. Additional Microsoft Graph capabilities for Azure AD users, such as SharePoint and Microsoft Teams, are facilitated by this V2 endpoint. The V1 endpoint enables access to Azure protected resources. In the V1 endpoint, we had to provide a resource parameter to identify which resource we were going to be requesting an access token for. Open source libraries were not able to easily incorporate into these different requests. Now we can use the scope parameter, which is supported by all the libraries, to compound the resource and the permission. Now, when you build applications with the Azure AD V1 endpoint, we had to register all the permissions the application needed, and the user consented to all the permissions statically, or they had to do it up front. With the V2 endpoint, we can now send scopes or permissions that you want access to at the time that you want them. You don't have to request it all up front. It also changed the contents of an ID token to better conform to the OpenID Connect 1.0 specification, such as using the preferred username claim instead of the UPN claim. In the past, if you needed a client app, single page app, a web app, and a web API, you had to create multiple registrations and wire up the relationships between each one of them. But the Azure AD V2 endpoint now enables one registration across a single logical application. We also have access to some well-known scopes. So you have things like the offline access. That's going to enable us to retrieve refresh tokens. OpenID is a scope that's going to allow your app to sign in the user and receive an app-specific identifier for the user. Email allows your app access to the user's primary email address via the email claim in the token. And Profile allows your app access to all other basic information such as the name, preferred username, object ID, as well as others. There are two primary endpoints for V2, the authorize and the token endpoint. Each of these can be scoped based on the tenant section of the URL. Either the friendly domain name of the Azure AD tenant, such as contoso.onmicrosoft.com, or the tenant's GUID identifier can be used inside that tenant piece. If you use common, that's going to allow users with both personal Microsoft accounts and work and school accounts from Azure AD to sign into the application. If you use organizations, it's only going to allow users from work and school accounts from the Azure Active Directory to sign in. Or if you use consumers, it's only going to allow personal accounts or Microsoft accounts to sign into the application. The resource mode indicates that the data should be returned in the query string or if it is posted back via an HTTP post. The demo that we're going to see uses a query string to easily capture and return the different data. The state parameter can be anything you want. Data in is going to be the data out. Using a randomly generated value for the state parameter is going to help you preventing against the cross-origin resource forgery attacks or CSFR attacks. The idea here is that someone can't go through and initiate a login process and redirect them over to your site without you initiating it. Because if you pass in the state, you can check the state, make sure that what the state you gave the user, that when they authenticated and when they're sent back from Azure AD, they're getting the same value back. The Click to Try link is an app that'll be redirected to localhost/myapp with a code that you see here listed in the on the demo here. You can use this to demonstrate the converged endpoint experience. You can log in with an organizational account, work or school, or personal account, such as a Microsoft account. Now, as there are changes in the protocols between V1 and V2, this is going to require a change in the SDK and a new conceptual model as well. The public client application uses a registered client ID. The confidential client application has a secret, which is a client secret or an X509 certificate. The Microsoft Authentication Library, or the MSAL, is considered to be the successor to the Azure Active Directory Authentication Library, or ADAL. This module is focusing on MSAL and the Azure AD V2 endpoint for the Microsoft Graph, not using the ADAL library or the V1 endpoint. Now let's talk about a JWT token. A JWT token is a JSON web token. And the JWT token is a format that is 3 strings separated by periods. You've got a header section, a payload section, and a signature section. The JWT token can be decoded, so it's required you secure apps using HTTPS. The token can be decoded using a tool such as the website jwt.calebb.net or jwt.caleb.net. Now, it's worth noting that the tokens are not encrypted by Azure AD today, but they might be in the future, in which case you would not be able to decrypt them. So I would definitely recommend that you take a look and read up a little bit more on JWT tokens and what the different values are. You can see in the payload, you've got a couple different pieces to it, like the audience. That's who the token is intended for. So you can think of that as like a key to your house. If I give you a key, it's only intended to get into my house on the lock on my door. You can't just take my key and go use it on someone else's house. So the audience for my key is my house. The issuer, that's the ID of your tenant. That's who gave you the key, or that's me. IAT, NBF, EXP, those are some other ones that are available to you as well. And those are time codes that are using the Unix epoch time, which is the number of milliseconds since a specific time. Now, all the tokens that are issued are JWT tokens. The format and the content of the ID tokens are consistent for the personal accounts, like MSA accounts, as well as work and school accounts. Access tokens requests include metadata such as the expiry and the scopes, which is going to avoid the need to parse the JWT token. Refresh tokens are often multi-resource. A refresh token can be received during a token request for one resource and then be redeemed for access tokens on a completely different resource if you wanted to. There's a link here on the slide where you can go learn a little bit more about working with the different Azure AD tokens. Now, registering an application is going to generate an application ID, which is just a GUID, as you see here on the slide. Creating an application secret is required because it's a web URL, like in the context of the Graph Client SDK, that's also considered a confidential client application, one that contains a secret. The client secret is required here because it's calling back to a web URL. It's not going to be required if you're using a native application. The authorized endpoint will prompt the user to sign in and to grant consent to the requested permissions. The response will be directed back to the configured redirect URL. A common configuration mistake is when the redirect URL does not exactly match one of the redirect URLs configured for the application, including if it is there with a trailing slash or not. The HTTP request to the token endpoint posts the body content. The result is an HTTP 200 OK that contains an access token. The refresh token is returned when the scope includes offline access. You can see that here in that second block of code that you see on the slide. On the second line after client ID, it says scope equals offline access. The ID token is returned when the OpenID permission is requested. You can see that there after offline access where it says plus OpenID. Some data, such as HTTP headers, have been omitted from the snippet that you see here on the slide just for brevity's sake. Now, the access token is used as the value for the authorization header in the GET request to the Microsoft Graph or any other request you're going to make. Here you can see on the second line of the request where it says authorization : space, and then the value is bearer space and then the token. It's actually a lot longer than what you see there on the slide, but I just cut it off a bit here for the sake of space. Some data, such as the headers that you see here, other headers have been omitted just for brevity's sake. But you can see where I'm pointing, doing an HTTP GET to the graph/v1.0/me endpoint. I'm using an authorization header and the host that I'm actually making the request to. And there you can see a response that's coming back. Let's take a look at a demo to see working with the authentication process and getting back tokens and such. So in this demo, we're going to use PowerShell to show how we can make REST API calls to Azure AD, obtain a token, and use that token to the Microsoft Graph API. So I'm going to first click Add an App and give it the name PowerShell REST Demo using the app registration portal. And then click the Create button. All right, so our application's been created. I'm going to need that application ID. I'm going to copy that and just stick that into a little notepad. So we're going to need that in a minute. And I'm also going to need to generate a new password under application secret. So I'm going to create this password. Now just keep in mind, this is only going to be shown one time. So make sure you get a copy of it while you can. So now I've got a user ID and password, or the application ID and password. I'm next going to add a platform. And I'm going to choose the web platform. My redirect URL, I'm going to point to localhost. So I need to map this value exact to what I'm going to use. So I'm going to use HTTPS, localhost 8089. And then if I scroll down, I don't need to grant it any additional permissions. So I'm going to just go ahead and click Save. So now let's go over to my PowerShell ISE. And I'm going to open up this PowerShell file that I have here, that you'll find in the lab that this demo matches up to. So I have a method here that's going to accept a credential called getUserProfile. It's also going to accept some scopes, a redirect URL, and a switch option to display tokens or not. So I'm going to pass in the credential, which is going to be a combination of the client ID and secret. So I'm going to use some PowerShell to extract from that credential object the client ID and client secret. I'm then going to call the Azure AD authorized URL using login.microsoftonline.com and using the v2 endpoint and the authorized URL. I'm then going to append in the scopes that I need on the authorized parameter. This is using the dynamic consent. The response type is going to be a type code. You see there on line 29. The client ID is listed on line 32, just basically creating a long URL here. And then I have another option here to how I want Azure AD to respond. Do I want to have the values provided back in the query string, or do I want to do an HTTP form post, as you see on line 40? Now I want the query string value because I want to copy those straight out of the browser's URL bar. So all the code that I've shown so far is just concatenating that big string. So then I'm going to take that string and paste that into the browser. So I'm going to take that request URL from PowerShell, paste it into the browser, and then that's going to have me go log in and through the browser. So then I'm going to copy the code from the query string, paste that here into PowerShell, and then that's going to form up the HTTP body. So then that's going to make another post, HTTP post, to the token endpoint, the v2 token endpoint for Azure AD, by passing in the client ID and secret, the scopes, the grant type is an authorization code. Then I'm passing in the code and the redirect URL. So those are provided to the token endpoint. So here I'm using invoke REST method with a post with the token URL, and the content type will be a form URL encoded. And the body is going to be that I just showed the previous line on line 51. And I also have a switch that you have at the top that says that if the display tokens are set to true, then I'm just going to grab all the properties from the response and list those out. So I'll be able to see the ID and the access tokens that are going to be returned. And then finally, I'm going to extract the access token from the response, and then I'm just going to invoke another REST method to the graph API to get the current user's profile and append the authorization header with the bearer token. So to call that, the scopes I'm going to use are the OpenID scopes. So for offline access, it's going to give us access to the refresh token. OpenID is going to allow us access to the ID token. The profile is going to give us basic information about the user, and user read is going to give us full permission to the user's profile. The redirect URL is going to go really nowhere. It's going to create a 404 in the browser, but I'll have the query string. So that's what I'm needing. That would be my application that I want to go harvest all that information from in a real app. So here, if I run this application, so now it's asking me for the credentials. So I'm going to grab the ID, which is the username for my application. And the password is the client secret. So I'll copy that, paste that in. And then PowerShell will prompt us to take that URL, paste it in the browser. So let's copy that entire URL, go back to the browser. So I'll paste that in. It's going to ask us to log into our application we just created. So I'll go ahead and choose my user. I'll log in as the administrator. It's going to be prompt me to grant permissions that were requested as part of the scopes. So I'll say accept. And this is what's going to redirect me back to a unknown or a bogus URL. And it failed because I don't have a web app running on localhost port 8089. That's fine, because all I care about is really that code. So if I grab that entire URL that we got back, you can see here we have a session state that's there. I need that code right there. So what I'm going to do is I'm going to take the value of that code, take that whole value, copy that, and come back over to PowerShell, and you see there it's waiting for the code. Remember, we saw that in the code. So I'm going to paste that in and hit enter. Now, what that just did is that just made a call back to the token endpoint to get a token. And here you can see all the stuff that came back from that token endpoint. So I have an access token. You can see I have a scope of user.read when it expires. And then there's my access token that was returned. So if I grab that access token, let's copy that. And if I can go over to a JSON JWT decoder, and I can pass in that token. And here you can see that this little utility is giving me the ability to decode this. And so you can see it's a JWT token. There's the algorithm that was used. And then I can see some other information like what's the audience, who's the issuer, and then also see the timestamps. Those are the Unix epoch times. So the IAT is when it was issued. NBF is not valid before that time, and EXP is for when it expires. And then there's some other properties about the current user and the current application. All this is part of our JWT token. So we've also can use that access token that was provided here to call the Graph API, because we said that this is what we wanted access to. And so that's the second part right here, where it's giving us some information about the current user. And you see here I'm getting things about the display name, their given name, and then their mobile phone and some other information about them. Now in this section, let's look at protocols in the V2 endpoint, specifically the authorization code grant, the implicit grant, the client credentials grant, and the OpenID Connect. Let's first talk about mobile and native applications using the authorization code grant in the V2 endpoint. These are called when you hear it referred to as the authorization code grant, this is also referred to as an OAuth flow. The call to common/OAuth/v2/authorize will pop up a login screen and request a permission consent. And it's important to cache the refresh token to the request as a new access token. So you see here, we're first going to make a call over to authorize, which is going to have the user log in, and if they haven't done so before, consent to any delegated permission requests. The application is then going to return back an authorization code to the application. I'm then going to have the application go to the token endpoint and pass in that code to obtain an access token. And it's going to give me the access token, a refresh token, and optionally a ID token as well. I can then use that access token in the third block that you see there to make a call over to the Microsoft Graph. And that's going to give me back, say, my user's profile. Now, if you say that if the authorization token expires, I can use the refresh token to call back to the token endpoint to get a new set of access token, refresh token, and ID tokens, and use that access token to then call the profile. Now, the Microsoft Authentication Library makes it easy to create applications that acquire a token and cache resources locally. The acquire token async method will look in the token cache for an access token that matches the current user and the scopes that I've requested. If the token isn't in the cache, or if the token's expired, it'll first attempt to use a refresh token to get a new access token without those scopes, or with those scopes. If one does not exist, then it will send the user over to an interactive authentic login. Notice the scopes are not fully qualified URIs that like we had in the V2 endpoint. Instead, they're very simple, just user.read. The Microsoft Graph applications can use this shorthanded version. Now, unlike the authorization code flow, let's look at the implicit flow. JavaScript applications using the V2 endpoint work similarly to other types of applications, but they use a flow type called the implicit flow. In this case, the call to token, let's say it again. In this case, the call to common/OAuth/v2/authorize is going to pop up a login screen and request a permissions consent. The access token is then going to be returned as part of the HTTP response, but notice it's an access token. It's not a code like we saw in the previous one. The MSAL library is going to handle the hidden sign-in requests when things expire, which is going to end up being transparent to the end user. They're not going to see anything happen behind the scenes. This flow is a lot easier to work with for client-side based applications, but it is also a little bit less secure than the authorization code flow because the user is still logging in the current context of the application instead of in an authorization code flow where the application essentially tells the user, go log in and bring me an authorization code flow back. Now, the implicit flow will cause an HTTP 302 redirect with the access token in the request. So you see how that's actually set up here. Now, the code for a JavaScript application is very similar to the code that we use for mobile and native apps. We are first going to attempt to acquire the token silently, and if that fails, we're going to prompt the user to go ahead and log in. And so you can see here that we're trying to log in, and it's triggering that login pop-up first. And if it succeeds, once it succeeds, it's then going to try and acquire the token silently. And if it fails, it's also going to try and log in again as well, but using the access token with local storage instead of just redirecting them. So if that fails, then it's just going to error out again, just saying I couldn't even acquire the pop-up instance there. Now, another type of authorization code or authentication that we can use with the Microsoft Graph and the V2 endpoint is called a client credentials grant. And this is great for services or that are otherwise known as like a daemon-based application. A daemon app or server-to-server or maybe even a headless app. You can call it any of these. A good example of this is an application that runs on a scheduled basis and doesn't have an interactive user. An admin is still going to need to grant the consent to the app initially, but then the app, once it's been granted consent, it can then log in on its own and do whatever it needs. An example of a request for this, well, I've got a URL to it in the notes on the slides. But here what you see is that once the admin's first going to grant consent. So you see there in that first request, I'm going straight to the admin consent endpoint and passing in a client ID and then a redirect URI and maybe even a state. That's then going to kick back the tenant ID of the tenant where this application has been granted consent. Now, once that's done, the application can then, without user involvement, can then go straight to the token endpoint and request an ID by passing in a client ID and its secret. You can think of this as almost like a username and password, but for an app, we call them client IDs and client secrets. That's going to get the access token, and then I can use that access token to make the call over to the Microsoft Graph. So here's what one of those grants actually looks like. So here I'm making the request for the access token, and you can see here the grant type, I'm looking for a code, and I'm also passing in the client ID and secret. Now, in previous instances, we used the public client application, which is going to include an interactive user. But in this case, I'm using a confidential client application, and that's going to be able to run without an interactive user. Obtaining tokens by providing a secret and using a secret in an app instead of just requesting the user to go get it. These types of applications are going to require the admin consent, as I covered previously. So first we're creating that client application, and then we're saying to that client application, go acquire a token for the client asynchronously. And I'm passing in the scopes and all that stuff to also go get my authorization value. Now the authorization that I get back, or the response I get back, is going to give me a token. So here I'm going back and getting from the initial request that I was making. I want to get from the auth result request, I want to get the access token. I'm using that inside of the request I'm making with the Microsoft Graph client. Now let's talk about OpenID Connect and the V2 endpoint. Now, the call to the authorization endpoint that you see there, the very first one, is going to pop up a login screen and request a permissions consent. This is how my user is going to sign into the application. The application is then going to get an ID token back, which it needs to then go ahead and validate. So it's going to validate that token and make sure everything is okay. Then it's going to call the token endpoint, passing in the code that came back from the authorized endpoint and request an access token, where it's going to get the access token, the refresh token, and an ID token. Then it's then going to issue another request to the Microsoft Graph. Now it's not going to need to validate the ID token that's obtained for the Graph endpoint. The Graph endpoint is going to perform its own validation, so I don't have to worry about that. So let's look at what the request and response is going to be for this. OpenID Connect with using an ASP.NET web application. In this case here, the request to authorize the endpoint is going to include the client ID. So you see that in the second line on the slide. The response includes the ID token and will cause an HTTP post back to your reply URL. The reply URL must match the reply URL that is configured for the application. You can't coerce it to reply to a URL that isn't configured to the application. That's just not going to be something permitted by Azure AD. Now let's talk a little bit about OWIN and the OpenID Connect middleware, as well as the V2 endpoint that Microsoft provides. The key point that I want to make on this slide is that this is using an ASP.NET middleware with a V2 endpoint. That middleware is called OWIN. The Microsoft Authentication Library, MSAL, is not required to sign in the user to the application. We can configure the V2 endpoint to use OWIN instead. We only need to validate the ID token to use to sign the user into the application. We do not need to validate a token that is used to call a downstream API, such as the Microsoft Graph. Now, let's talk a little bit about using MSAL with ASP.NET MVC apps. Once a user is signed in via the OWIN middleware, the application then uses the MSAL to call a downstream API, such as the Microsoft Graph API. The OpenID Connect middleware receives a code as part of the OAuth flow. MSAL redeems this code using the acquire token by authorization code async. Let's say this again. MSAL redeems this code using an acquire token by authorization code async method, obtaining a token using the scopes that have been provided. So in this demo, we're going to look at using OpenID Connect as part of the demo here. So I'm first going to start at the application registration portal to create a new application, and I'm going to give it the name OpenID Connect Demo, and I'll use my URL and then just go ahead and click Create to create a new application. So here's an application ID that was generated for us. So I'm going to copy this and put this in a little notepad because we'll need this later. I'm also going to need a new password. So I'm going to click Generate a New Password. So again, just like the last demo, I'm going to copy and put this inside of my little notepad from a scratch pad here. Now I'm going to need to add a platform. So I'm going to choose the web platform. This is going to influence the OAuth flow that I'm going to use. So again, I'm going to choose web. And I need to give it a redirect URL. Now the redirect URL is just going to be localhost. So I'm just going to use this 44326. And now I don't need to do anything else here. Everything else is fine the way it is. So I'm just going to go ahead and click Save to create our application. Now, the reason why the 44326 is because I'm going to use this to host an application here. So I'm going to clone an existing GitHub repo from the Azure AD samples. So I'm going to pull this one called Azure Active Directory .NET Web App OpenID Connect v2. So I just cloned that. So I'm going to then go to that application and open it in Visual Studio 2017. So the first thing I need to do inside this application is to open up the web config and make some changes here to have it match the one that we just created. And I could use the one that they gave us that we got by default from the directory. There's one that they leave there for us for use for testing, but I want to use the one that we just created. So I'm going to go change the client ID to be the ID of the application I just created a moment ago. And now let me grab the secret, and then I'll replace that. And then you can see the URL, the redirect URL. Now you see why we chose the URL just a moment ago in the demo. So, and the reason I'm doing that is I want to make sure that matches whatever this application is set up. And so this one has already been set up to host the 44326. This value has to match what's in the app registration. So that's why I chose that specific URLs to save some stuff I was going to have to change. Well, let's take a look at our application. So if I go under app start and I open up startup.auth.cs and scroll down. So you can see here I'm actually missing a couple references inside of my app. So I'm going to go and build my solution first. And that's what that's going to do is first go pull in all of the NuGet packages that were referenced inside of this project, but have not been downloaded because we just cloned the repo. So here, inside the startup auth.cs file, we're going to set the default sign-in type to be cookie authentication. And so here we're going to be using cookies here for our authentication type. Specifying just a couple of things about the authentication here. So there's a little bit of stuff here I'm doing here to get around like the dynamic permission scopes. We're going to look at that in the next demo. So I'm just going to table that for now. So here I'm defining a couple scopes a little farther down in the authentication. So the scopes you see listed here are the ones that are going to be listed in the permission grant. So here, OpenID, email, profile, offline access to get access to the refresh token, and then mail.read is to get access to the current user's mailbox. Now if I scroll down a bit farther, now once I receive the token, or more specifically, once I receive the code using OpenID Connect, I'll then take that token or take that code, and that code is going to look just like the process that we looked at in the previous demo where we're using PowerShell. Once we redeem that code in exchange for a token using the Azure AD token endpoint. So I'm going to create a new token cache. And I'm going to do that by creating a new MSAL session cache, which says store all the tokens inside session and create a cache out of it. You could implement this however you wanted. If you wanted to go change this and use like a database or something, or like say a Redis cache, it's up to you. In this case here, it's just using a session cache. So here I'm then creating a client application. The client application is using just the app username and password. There's other options available to me, but in this case here, I'm using just the client credentials. Now, once I have that, I'll give it the scope, which is mail.read, and I'll go get the token. And that's what's going to be calling the token endpoint to go fetch the token. I don't have to pass the URL in here because it's a well-known URL, and the NuGet package that we're using knows where to call that. So you can see here we're passing in just really the code and the scopes. It's the only thing that's special about this. So once I get that token back, MSAL is going to store not just the access token, but also the refresh token. It'll automatically store that in that token cache that I defined earlier. So later when I need a token for that scope, for that user, it'll check to see in the cache, do I already have it? And if I do, then it won't call Azure AD for yet another token. It just does it one time. So that explains kind of how the OpenID Connect stuff works. Let's go take a look at the controllers. So in the controllers, we have a home controller. And in this home controller, we have a few methods. So in our index method, that's just really just going to kick back a view. So there's nothing really special here. But what you see there is lines 25 through 27 that we're pulling the values out of the app settings for our Azure AD application. Now, if I jump down to read mail to see something a little more interesting here, now what this is going to do is it's going to figure out who the currently logged in user is. It's going to create a new MSAL session cache using the current user and the current HTTP context. So for the current session, the current user session, and it's going to get an instance of the cache. It's then going to create a new client credential application, passing in all the stuff you saw just a moment ago to do all the authentication stuff. And then we're going to pass in the scope, and we're going to ask it to go get the token. And you see it's using the word silent there in the name of the method under acquire token silent async. That's the thing that's going to try and use the session cache, the local token session cache that was defined. And if it finds a token, then it'll use that. If it doesn't, then it'll go run the user through the process of trying to get a token. If that session cache has a token that is expired, it'll use the refresh token to get a new access token without prompting the user. So that's why it's got the word silent in there. So once we've gotten the token, we'll then set the bearer authorization header, and then I'm then going to issue an HTTP GET request to the Microsoft Graph asynchronously to get all the messages for the current user. And then I'll just read all that stuff coming back as a string and then just show it on the screen. So I'm going to go ahead and hit F5 to build and run my project. This is first going to prompt me to log in. So I'm then going to click on sign on with Microsoft. I'll then use my current user that I've been using for my demos. So I will pass in the password for my current user. Here it's prompting me to delegate permissions because remember, this user's not used this application yet. And so I need to have this user grant the application delegate access to my application. So then I'm going to click the accept button to grant it those permissions. That'll take me back over to my application. So I'm all logged in. Everything looks good. I've got the current user logged in. So we know that the authentication flow has worked. Now, let's see if this works for reading email from Graph. And sure enough, we're seeing a bunch of data coming back here in this big JSON blob. But what you're able to see here is that this is giving us just really the big JSON response. And we could parse this out, though, to write our email. But you can actually see that we're getting all these emails back from our current user. Now, the next one will show you how to use dynamic permissions. So the next demo will show you how to use dynamic permissions. In this final section, we're going to talk about scopes and consent in the V2 endpoint. Specifically, we're going to talk about scopes and permissions, OpenID Connect scopes, delegated versus application permissions, the permission names for the Microsoft Graph, individual user consent, admin consent, and dynamic consent. In Azure AD and in OAuth, these type of permissions are called scopes. So we have web-hosted resources that integrate with Azure AD and have a resource identifier. So for example, like Office 365 has outlook.office.com, the Azure AD Graph API has graph.windows.net, and the Microsoft Graph has graph.microsoft.com. Resources define their own permissions, such as calendar.read, profile.read-write, and mail.send. OpenID also has their own scopes. So OpenID has one called OpenID. We have one called email, one called profile, and one called offline access. And we've talked a little bit already in this module for what each one of these are, but this slide goes into it in a little more depth. Let's talk a little bit about delegated versus application permissions. For delegated permissions, this is the effective permission of your application. It's going to be the least privileged intersection of the delegated permissions the app has been granted access to via consent and the privileges of the currently signed in user. The app can never have more privileges than the currently signed in user. Application permissions are a little bit different. The effective permission of your app will be the full level of permissions that are implied by the permission. For example, if an app that has user.readWriteAll application permissions, it can update the profile of any user within the organization. Now, the permission names for Microsoft Graph app-based applications are going to follow the pattern of resource.operation.constraint. So the all constraint, for example, is going to potentially grant the application access privileges to read all the profiles of a user in a directory in the case of user.read.all. As far as the shared one goes, if you use, for example, mail.read.shared, that's going to grant privileges to read mail in the mailbox of the signed in user, as well as the mail and mailboxes that other users in the organization have shared with the signed in user. And if you have none, well, user.read without anything on the end is going to grant privileges to read the profile of the signed in user only. And mail.read only grants permission to read only the mail of the mailbox for the currently signed in user. Some permissions don't require an admin consent. Each individual can individually grant consent to the application. So in this case here, the application says it needs access to, say, get access to your profile. And so I can grant it access to do that. That's called user consent. Now, if an application attempts an operation that was not in the original permission request, or if the user didn't grant consent, I'm going to get a 403 forbidden back. So for example, the scope requested is user.read, and the operation that I'm trying to do is mail.send. Well, that's going to fail because the mail send permission was not requested and thus granted by the user. So this is an example of some of the graph permissions you could grant your application. There are a lot more available to you, but this is just a small sample. The application registration portal allows you to specify which permissions your app is going to need. This section is only used for admin consent. An application can dynamically request additional permissions, so as long as the requested permission does not require an admin consent, you could go and ignore all the delegated permissions here and just hand them off. Now, some of the applications, in this case here, it's requesting a couple permissions in this example. So for example, delegated mail.read, it doesn't require admin consent, but reports read all does require an admin consent. User read all for the application would definitely require an admin consent because the administrator, the global tenant administrator, would have to grant the application access to do this for all users in the organization. Now, some operations are going to require administrators to consent. So if a non-administrator user tries to attempt to use the application that requests permissions requiring admin consent, you'll see this error message show up on the screen. It's going to say you don't have access to it. You need an administrative account. So if you have one, then you can log in with that account. If you don't have one, well, then you're going to need to get an admin to go set that up for you or to go grant the permission for you. Now, an administrator or an admin can pre-consent to the permissions for all users in the organization for delegated permissions. Now, note the little paragraph that you see there at the bottom. That paragraph there is going to let you know that this is going to grant this permission to everybody in the organization. So if you agree to this, then the app will be granted access to the specific application permissions to the resource that are belonging to all the users in the organization, and the delegated permissions to the resource then belonging to the signed in user. If an application requires additional permissions that require admin consent, you can direct the user to the admin consent URL where they can then will have to log in, but they'll have to be logged in with someone with administrative rights to do that. So this is an example of what a dynamic consent is going to look like. In this example, we have an app that is requesting a token that includes the mail.send scope that you see there somewhere in the middle of the screen there, where we have an array of scopes that are being defined. That has not been consented yet. So when I call acquire token silent async, it's going to look in the cache for a token that matches the user and that scope. Then it's going to try to refresh the token. When it fails, the user is going to be notified of the missing scope. That's the MSAL UI required exception that we are then going to want to redirect the user to go get an authorization request and redirect them to that link, or at least present that link to them and say, hey, we don't have the necessary permissions. I need you to click on this to go get those permissions. So here's an example of when I need to go get one of these admin consents or one of these extra consents here. The user is first going to be then prompted to sign in. So they're going to the site, they go to log in, and they're prompted to log in. Then once they log in, they're going to be presented with the consent dialog, and that's the middle screen that you see there. So it shows, here's the application that is requesting permissions, here's the permissions that's requested, and then here's how you're signed in. If you granted that access, then the app can then perform the requested operation. So you can see here where it's saying, I want to send mail as you in the middle screen. Then that would then allow me to send mail as you see there on the last screen. So in this demo, this is really a continuation of the previous demo that you saw earlier, where I showed you how to create or take an existing Azure AD application or create an Azure AD application, take an existing project and make some customizations to it to be able to use our new custom application we created to see email coming back or read email using the Microsoft Graph inside of our ASP.NET application. So I'm going to jump back over to the app registration portal, and we've already got our application that we created. And so we have an application ID for this application. We've got a secret that we can use for this application. The redirect URL is the same thing that we had before. It needs to match the project that we're going to be working with. And if I scroll down to the permissions, the only permission that we have listed here is user.read and the delegate permissions. Now, our application is going to not only read mail, but it's going to need to also send mail. Now, users can grant consent to a URL. Unlike in Azure AD v endpoint, we had to specify all the scopes or all the permissions ahead of time. We couldn't dynamically add permissions. But in the v2 endpoints, we can actually use dynamic permissions, so we can request additional permissions as we go along. So I'm going to go ahead and click Save here. So now let's come back over to our application, our ASP.NET application. So here, I don't have to make any changes to it because this is the same one that we had before. So we had client ID and secret is listed here. So same client ID, same client secret, same redirect URI. So let's jump over to the send mail controller and let's see how this differs from what we did before. So we're doing the exact same pattern that we did before, where we created a confidential client application, passing in the client ID, the URI, the app key, and the user token cache that we provision. But what's different here is you see that we're telling it the scope that we want is mail.send. If you recall, we did not specify that inside of our Azure AD. Now, then on line 62, we're trying to acquire a token silently, and it's not going to find it for this because we don't have a mail.send, because the user hasn't not only granted the permission to it, but the application didn't have that defined. So we're going to get a MSAL UI required extension that's going to be thrown. And there on line 64, what that's going to do is it's going to tell our user that they need to have an interactive sign-in. So now what I'm going to do is I'm going to manufacture a URL, the authorization request URL, and assign it to the view bag, the authorization request. So let's take a look and see what this looks like. The generate an authorization request URL. Let's just jump to the definition and see this guy real quick. So what this is going to do is this is coming from the NuGet package. But what this is doing here is it's using the confidential client application to get the redirect URI for our user, and it's going to build up an entire URL here to do a new authorization request. But this new one is going to have the mail.send scope that we need for this application. So it's going to make the user go through the consent prompt again to grant this additional permission that it needs. Now, when I get that URL back, or when I get the redirect back to the user, so let's go look at the views real quick. And under the home views, we have a send mail view. And here, under send mail, we're going to check to see if the view bag authorization request is not equal to null. And if it isn't equal to null, then it's going to say this page requires you to grant additional permissions. Click here, and that's going to be the URL. It's going to take them back to the authorization page to get the code grant. So now let's just see this run. So I'm going to hit F5. It's going to take me to my send mail controller. So let's first go log in the first time. So I'll go ahead and log in using my current user. So here, notice here that of the permissions I'm getting, we don't have it say it's going to send email under the context of the current user. It just says it's going to read email, because right now we're just trying to load the page. And remember, that first time it's running, we have not granted it access to send mail. So here, what it's doing is going and getting the token, and it's going to try to go send a mail on our behalf. But as the code you saw a second ago, it says that the code we don't have the permission to actually go send a mail. We can read because we have a token for read mail, but we don't have one for sending. And so what it did is it created a new authorization code that we can click on. It's going to prompt us to go log in again. But this time when we go to log in, notice that it now says send mail as you. So this is different. This is giving us an additional permission that we need. So this is going to add it to the list of permissions that this current user has granted the current application to do things on my behalf. And so now I'm going to go ahead and click accept. And now when I go to the send mail, now you can see that I have permissions to send mail on behalf of this current user. So now I'm just going to go through and send a mail to myself. So I'm just going to copy my email address in here. I'm just going to put a sample subject of permissions worked, and just creating a little sample message of this is awesome. I click send. And now when I go, and now I just successfully sent a message to myself, and I go back to read mail, I should be able to see the mail that was just created. So there we go. We can see our this is awesome email that we just sent to ourselves. So this is a dynamic permission grant demo using OpenID Connect using the V2 Azure AD authorization endpoint.